solutions. So you might have studied in your previous classes about the mixtures, that is homogeneous mixture, heterogeneous mixture, and colloidal mixtures. Okay. So in this chapter, we are going to study about solutions. So what are solutions? This chapter is basically for the study of binary solutions. All right. What are binary solution? Where we are using only two components in solution. For example, if you read the introduction here, if you can see here, in a scorching day and you just came from school, all right? So we are talking about the summer days when it's a very scorching, heatful day, in summer day, and you came from school and you see a bottle of chilled water, all right? But you wanted to make it cooler. So what do? You add ice in that, right? So do you find any changes scientifically when you add ice cubes in water? No, right? It still remains the water, but it turns cold. Now to make it more tasty, you add a spoonful of sugar in it. Now, is it still a pure water? No. Why? Because we have added a new component to it. And what that component is? Sugar. All right. So what exactly is this substance formed by adding sugar to water? When sugar is added to water, it becomes a mixture, right? And that specifically is called a solution. So that means what is a solution? It's an impure mixture, or say mixture of two or more than two substances. So what is a mixture? Mixture of two or more substances. All right. So in this chapter, we are going to study about binary solutions only, where we are taking two or more than only two components in a solution, right? So let us start with our chapter. The first subtopic is types of solutions. Okay. Right. One second. Types of solutions. Do you know how many types of solution are there? Basically, there are three types of mixture that forms a solution. So what are these two mixture? As I have told you that in the previous classes, you have studied about homogeneous mixture and heterogeneous mixture. There is one more mixture that is called colloidal mixture. So let me give you a quick overview that what are these mixture. Mixture, as you know, this is where we take a solute and add solvent to it. Okay, that makes a mixture, as we just learned about the sugar solution example, right? So what are homogeneous mixture? Homogeneous mixture is that you where you cannot see the components or constant particles separately. So as you can see here, homogeneous mixture, they are having uniform composition. By uniform composition, we mean where we cannot see the constituent particles, where we cannot see the components, or say the constituent particles present in mixture. Okay, best example for this is sugar and water. Okay, so as you can see in this picture, when we mix, example of homogeneous mixture is say perfume, right? Other example is perfume. As you know, you must have seen a bottle of perfume. By looking at just the perfume bottle, you cannot tell that what constituent particles or what components are present in it. So this is an example of homogeneous mixture. What other example can you think of? Can you tell me other example? Say alcohol in water. When you add alcohol in water, it becomes homogeneous solution. Okay? That means clear solution where you cannot see the components present in the solution. All right? And what is heterogeneous solution? That is completely opposite to homogeneous solution or homogeneous mixture, where you can see the constituent particles. As you can see here, the example of heterogeneous mixture where sand is added to a glass of water and you can clearly see this heterogeneous mixture. We can also say that this is colloidal mixture, right? So where the components, they does not get mixed throughout the solution and they can be seen easily, all right? Where the components present in the mixture, they can be visible easily, all right? So any mixture from where we can't see through, that is called heterogeneous mixture, and the clear solution and clear mixture, that is homogeneous mixture, right? So what other example could be for heterogeneous mixture? One is given here, sand plus water. What other example? Say oil plus water or oil in water. Okay. If we put oil in water, we can easily see the oil floating over the surface of water, right? So this is an example of heterogeneous mixture. I hope the homogeneous and heterogeneous mixture are clear to you now, right? Now, what is a colloidal mixture? Colloidal mixture, a mixture that is actually heterogeneous mixture, but it appears to be as homogeneous. The solution, it mixes throughout, right? The mango solution, it is completely mixed, right? Although we cannot see through it, so it appears as heterogeneous, but appears as homogeneous, but is heterogeneous, right? So this is all about the basic knowledge for types of mixture, homogeneous and heterogeneous mixture. I hope this is clear to you. Next, we are moving to the types of solution, which is the main topic of our chapter, the table, the types of solution. So basically, there are three types of solutions: gaseous solution, liquid solution, and solid solution, right? So in this chapter, we are going to study about binary solutions only, okay? So before starting with this, let me clear you what is a solvent and what is a solute, right? So a substance that is present in larger quantity, okay? This a substance or say a liquid that is present in larger quantity, that is called solvent, and the other substance that is present in smaller quantity, that is called solute. Like if we take an example of, if we consider an example of sugar and sugar solution, we add sugar in water where we take sugar as solute and in smaller quantity, and solvent, that is water, in larger quantity, and they on combining make a sugar solution, right? So here first we are going to study about gaseous solution, and this whole table is categorized on the basis of solvent present in the solution, right? As you can see here, in gaseous solution we are taking gas as a solvent, and what is varying here, solutes, okay? In first example, as you can see here, we have taken gas as a solvent. So in all the three categories, whether it is gaseous solution, we are taking solvent gas. In liquid solution, we are taking liquid as solvent, and in solids, we are taking solid as solvent, right? And solute, all the three categories, that is solid, liquid, and gas. So what happens when we mix or when we make a mixture of gas in a gas? Now, as you can see, a basic example of gaseous solution is air, right? Air is everywhere and it is a gas. What is an air? It's a mixture of gases. But as I have said that in this chapter, we are only going to study about binary solution in which two components are present. So that is why we have taken an example of a mixture of oxygen and hydrogen gases, right? The next is gas in liquid, where we are taking gas as solvent and liquid is present as solute in there, right? Chloroform with oxygen gas. Here you can see the gas would be present in the bulk form. Oxygen, that is a gas, it would be present in bulk form in gaseous solution, and the solute will be present in smaller quantity, right, as mentioned here, right? Next is gas in solid. This is a very common example. Camphor in the air, or you can see if I write here the naphthalene balls. Naphthalene is what? A solid ball, right? And it changes into gaseous state, right? So this is an example of gas in a solid or camphor in the air, right? One solid particle which directly changes into gas, right? So this is an example of gas in solid. Let's move on to the other solutions. Liquid solution, as usual, we are having liquid in larger quantity present here as a solvent and the solute in smaller quantity. First example of liquid in gaseous solution is carbon dioxide in water, right? We can add another example here that will be of Coke, okay? As we have seen, you might have seen in the normal cold drink bottles, there is a gas present in the water, right? In cold drinks, gas is pressurized into the liquid, which is an example of liquid in gas solutions, right? Next is liquid-liquid solution. Here we are having an example of methanol dissolved in water. What other example we can use for liquid-liquid solution where solvent will be liquid and solute will be liquid? We can use alcohol plus water, right? Right. The next for liquid and solid as salt dissolved in water. Say salt solution, sugar solution, all right? The next is solid solution. This is actually a very rare case where we are taking solvent, a solid, right? So first type of solution, solid solution is where we are taking solvent, a solid, and solute, a gas. An example for this is carbon dioxide in fire extinguisher, right? To understand this better, we can take an example of sponge, right? Or say cake. Cake is a solid, right? And it has, some spots like this or say vacant spaces in it through which gas pass, right? While baking, gas passes through it and which can be termed as a space for gases, right? So carbon dioxide used in fire extinguisher, that is also a solid and gas example. And sponge or cake, they are also an example of solid solutions, right? For the next category, where we are taking solid as a solvent and liquid as solute. We have taken here gelatin example. You can also use an example of amalgam. Okay. Amalgam is what? It's an alloy of mercury, okay, in sodium, right? Sodium is what? It is, we have taken liquid at room temperature. So amalgam of mercury in sodium is also an example of solid liquid solution. And the other, last one is solid solid solution. It can be any metal metal interaction where we are adding metal to metal. It can be gold, copper, silver, right? Say bronze, alloy itself, as one example is mentioned here, where brass is an alloy and it is formed by solid copper and solid zinc, right? So solid and solid, it is an example of solid solutions. So can we just add these solid and solid or metal and metal? Can we directly add them? No. So here's a point to be noted that to make a solid-solid solution, specifically solid-solid solution or combining metal-metal, we need to melt them first, and then when we melt them first, they came into their liquid states, and then after solidifying, we can make an alloy, that would be a solid solution.